For our last video on induction, we're going to resume our divisibility proofs. This time we have a little bit uglier of an expression. We claim that this 8 to the n minus 3 to the n is divisible by 5 for any n in the positive integers. For this, let's get right to it. We're going to begin by proving the base case. The base case for this, just like the previous problem, is going to be n equals 1. So we need to check that 8 to the 1 minus 3 to the 1 is divisible by 5. Hopefully we can see that 5 is clearly divisible by 5, which is divisible by 5. I'm going to quickly comment on a notation that could help with some of these problems. Writing out in English can be tedious. Sometimes you can write this as 5, and then a vertical bar, the expression that we wrote down, 8 to the 1 minus 3 to the 1. That reads as 5 divides 8 to the 1 minus 3 to the 1. It's the same as saying is divisible by. So that is a notation you could have used. Rather than getting caught up in all these number theoretic notations, though, we're just going to avoid that for now and stick with our basic English that we can use. So we're going to write down our inductive assumption. Just like before, we're going to assume that it holds for P of n. Assume 8 to the n minus 3 to the n is divisible by 5. Divisible by 5. And we want to show that 8 to the n plus 1 minus 3 to the n plus 1 is divisible by 5. So, just like before, we're going to start with the n plus 1 looking thing and then try to do whatever algebra helps us get to our final answer. So we consider 8 to the n plus 1 minus 3 to the n plus 1. I want to try to make that look like 8 to the n minus 3 to the n so that I can use my inductive hypothesis. This is equal to 8 times 8 to the n minus 3 times 3 to the n. That seems like it's helpful because now I have 8 to the n's and 3 to the n's in the problem. But there's this problem where I can't factor something out of that nicely because the 8 and the 3 can't be combined in a nice way. Exponentials do not work well with addition. So instead, what we're going to do is rewrite that 8 in a sort of funny way as 3 plus 5 times 8 to the n minus 3 times 3 to the n. And then I'm going to distribute the 8 to the n, and we get 5 times 8 to the n plus 3 times 8 to the n minus 3 times 3 to the n. And now maybe it looks like it was a good idea because I can now factor a 3 out of that last term and write this as 5 times 8 to the n plus 3 times 8 to the n minus 3 to the n. And now 8 to the n minus 3 to the n is the same exact expression that I had up here. So by inductive assumption, by inductive hypothesis, there exists a k such that 8 to the n minus 3 to the n is equal to 5 times k. It was divisible by 5, and just like when we had divisibility by 3, we write that as 5 times some integer. Maybe I should again clarify that this k is in fact an integer. So let's do that quickly to make our proof more mathematically correct. And now we're going to try to use that fact. We write this as 5 times 8 to the n, nothing doing there, plus 3 times that expression that I highlighted in green we're replacing with 5 times k. And now, remember, our goal is to show that this is a divisible by 5. So we're going to factor a 5 out of that. And we get 5 times 8 to the n plus 3k. And just like in our previous examples, that thing there, 8 to the n plus 3 times k, is an integer. So since that thing, 8 to the n plus 3 times k, is an integer, the original expression, 8 to the n plus 1 minus 3 to the n plus 1, is divisible by 5. Divisible by 5. Therefore, P of n plus 1 is true. So, the result follows by the principle of mathematical induction. Mathematical induction. So this is another example where we had maybe some more interesting algebra going on. There's a bunch of clever algebra tricks you can do. Things like adding and subtracting by the same number, multiplying by 1 in a clever way, the sort of algebra tricks you may have used in the past, whether it be in calculus or whether it been in high school or some other class you've taken. There's lots of different things you can do to try and work with these problems. In this case, I wrote 8 in a particular way to help me solve the problem. There's not necessarily a formula to follow for this other than knowing your goal. In this case, I knew what to do because I knew somehow I had to make it look like 8 to the n minus 3 to the n. So I just kind of worked with stuff. You may not do this on your first try, though. You may try something and it might fail. That is completely fine. Just make sure you don't lie about what you're doing. As long as you are consistent and don't do any incorrect mathematics, your proof will be correct. So just make sure that you're consistent with that, and you should be fine for any problem involving induction.